Hello everyone and welcome back to physics class. Today we are going to continue on the topic of forces, and I would like to talk to you about the force that typically opposes gravitational force, and that is the normal force. Now, the normal force is a reaction force. That means that it is acting when there is another force that's happening. Now, this reaction force is exerted on a body by the surface that the body is in contact with. And most often, this is the force that opposes gravity, although in some cases, it's not necessarily opposing gravity, but opposing other forces. Let's take a look at this very simple example of a box resting on the ground. We know that gravitational force pulls the box down, and we know that because it's on the ground, the box isn't actually moving even though gravity is pulling it down. The reason it's not moving is because the ground is exerting a force called the normal force. It's a reaction force on the box that's causing it to move up. Now, these forces actually cancel each other out so that the box is not moving at all. We will often write the formula for this basic scenario as Fn is equal to the negative of Fg. Negative because it's the opposite direction. Now, the reason why we call this the normal force is because the force is always perpendicular to the surface. So if I were to extend this here, we would see that the force itself is perpendicular to the surface of the ground right here. If we had something on a slant, a box on a slant, the normal force would be coming up at an angle like this, and it would form a right angle with the slant. Normal in physics means perpendicular. So that is why we call it the normal force, because it's basically saying that this is the perpendicular force. Now, let's take a look at an example of how to calculate the normal force for a very simple example like this one here. Let's say that this box right here has a mass of 13 kilograms, and we want to find the normal force. The first thing we want to do is we want to find what our gravitational force is, because the normal force is dependent on the gravitational force. So, Fg is equal to m times gravitational acceleration. So 13 times negative 9.81 will give us a gravitational force of negative 127.5 newtons. Now, since the normal force is the same magnitude but the opposite direction, we can say that the normal force is equal to the negative of negative 127.5, which is actually positive 127.5 newtons. And that's how you find the normal force for a simple example like this one. Now, sometimes we're going to have an object on an angle, on a slant like this here. Now, when we calculate the normal force of an object on a slant, we can't just use the formula Fn is equal to negative Fg. We have to take into account the angle, because here we have gravity pulling straight down like this, but our normal force is pointing at an angle like this right here. So we have to take into account the angle. So in this case, the formula for an object at an angle is written as Fn is equal to negative Fg times the cosine of theta. So let's take a look at an example on how to calculate this right here. Let's say that we have a box here and it has a mass of 5 kilograms, and let's say that the angle here is equal to 15 degrees. We want to calculate the normal force. So, first thing, calculator Fg. Fg is equal to mass times gravity, so 5 times negative 9.81 will give us negative 49.1 newtons. And then we go to use this formula right here. the normal force, is equal to the negative of Fg times the cosine of our theta. So negative 49.1 times cosine of 15, and that will give us a normal force of 47.4 newtons. And that's really all there is to it. Thank you for listening, and I will see you guys next time. Bye!